The rule for multiplying decimal numbers is a little more complicated than the rule for adding decimal numbers. Suppose we want to multiply 0.7 by 0.4. We can change each of these to fractions by writing 0.7 as 7/10 and 0.4 as 4/10. Now you know when we multiply fractions, we multiply numerators and get 28, multiply denominators and get 100. Now 28 over 100 is 28 100ths, or 0.28. So if we were just to simply multiply 7 times 4, we would get 28, and then the 28 right here, the decimal point goes in front of that, and that turns out to be the same number of digits to the right of the decimal point in the answer that are to the right of the decimal point in both the numbers we multiplied to start with. So our rule to multiply decimal numbers is this: multiply as if there was no decimal point. Simply multiply the numbers involved. The decimal point in the answer is placed so its digits to the right equal the total number of digits to the right in both of the original numbers. Let's go to the board now and look at our first example. Let's do this multiplication again by changing to fractions, just so we can see exactly how this works. This is 7 over 100 times, this is 2 tenths, hundredths, thousandths, so 2 over 1,000. Now if I was to multiply these two numbers right here, I would get 2 times 7, which is 14, and then 100 times 1,000 will be 100,000. So if I wanted to change this back to a decimal, this would be 0.10ths, hundredths, thousandths, 10,000ths, 100,000ths. So you can see that as a decimal, this number 1,400,000ths looks like this, 0.00014. Now if I was just to apply my rule for multiplication, I would multiply 7 times 2 and get 14, and then I would count all the digits to the right of the decimal point in both the numbers I multiplied to start with. Here's 2 digits plus another 3 digits, that's 5 digits to the right of the decimal point. So I have 1, 2, 3, 4, 5, and then I put my decimal point in, and of course I put that leading 0. So when I multiply the numbers without going back to writing them as fractions, I simply multiply the numbers in the problem. 2 times 7 is 14. I have to have as many digits to the right of the decimal point in the answer as there are to the right of the decimal point in both the numbers I started with. Let's try another one. 75.14 times 2.5. Let's just multiply as if there was no decimal point involved. 5 times 4 is 20. Carry the 2. 5 times 1 is 5, and 2 is 7. 5 times 5 is 25. Carry the 2. 5 times 7 is 35, and 2 is 37. I go to this number right here, so I put a 0 to hold that place. 2 times 4 is 8. 2 times 1 is 2. 2 times 5 is 10. Carry the 1. 2 times 7 is 14, and 1 is 15. Now I add in columns. Here I have 0. 7 plus 8 is 15. Carry the 1. 5 and 1 is 6, and 2 is 8. 5 and 1 is 6, 7, 8, right. 7 and 0 is 7. 5 and 3 is 8. And 1 plus 0 is 1. Now I look to my original two numbers, and I have 1, 2, 3 digits to the right of the decimal point in the original two numbers I multiplied. I need exactly 3 digits to the right of the decimal point in the answer then. So that's why I put the decimal point there, because there's 3 digits here, and there's 1 plus 2 digits here, and that's a total of 3 digits. So that's the rule for multiplying decimal numbers by hand. Simply multiply as if there is no decimal point, and in your answer you have to have as many digits to the right of the decimal point as you did in both of the numbers that you started with. Here's some other problems. First, we'll simplify inside these parentheses right here. I have 3.5 minus 2.6. So 3.5 minus 2.6. 6 from 5 I can't do. I borrow 1 there. Make that 15. 6 from 15, I'm going to get 9. 0.9. So this now is 2.1 times 0.9. Okay, let's just multiply 9 times 21. 9 times 1 is 9. 9 times 2 is 18. I have 2 digits to the right of the decimal point in the two numbers I multiplied to get this 189, so the decimal point needs to go there so that I have 2 digits to the right in the answer. So 1.89 for the answer to that. It looks as though maybe you want to apply the distributive property to this, but you would get the same answer, of course, but it would take a little bit more work because I would have to multiply 2.1 times this, then 2.1 times this. That's 2 multiplications, then a subtraction, rather than a subtraction first and then 1 multiplication. Let's look at another example. Here I have 2.5 plus 10 times 4.3 quantity squared. I need to take care of this first. So let's multiply 4.3 times 4.3. 3 times 3 is 9. 3 times 4 is 12. Put in a 0. 4 times 3 is 12. Carry the 1. 4 times 4 is 16. Plus 1 is 17. I have 9, 4, 8, 1. 2 digits to the right of the decimal point in the numbers I multiplied to get this, so 2 digits to the right of the decimal point here. Now I can change my problem to 2.5 plus 10 times 18.49. Now when I multiply 10 times 18.49, I'm simply going to move that decimal point one place to the right. So this is going to be 2.5 plus 184.9. Now, to add these two numbers right here, I would line up the decimal points. I think I can do this just in my head. Let's see, 5 plus 9 is 14. I would carry the 1, 2, and 4 is 6, and 1 is 7. And then I'll have the 8 and the 1. And my decimal point will go right here. So 187.4. And what I did is I took care of this exponent first, 4.3 squared. I did that multiplication. Now when I multiply by 10, I simply multiply as if there's no decimal point here, so I get 18490. Then I'd have to move 2 places over. That would be 90, and I just don't write the 0. Multiplying by 10 simply moves that decimal point one place to the right there. Now I have these two numbers. If I lined up those decimal points to add, it would be 9 plus 5. That's 14. Carry the 1, so on and so forth. I get 187.4. Let's go on now and look at a word problem. Problem number 5, suppose it costs $15 per day and 12 cents a mile to rent a car. What's the total bill if the car is rented for 2 days and is driven for 120 miles? Well, it's rented for 2 days and it costs $15 a day, so I'm going to have 2 times 15 for the daily charge, and then I drive 120 miles at 12 cents a mile. I'm going to have 120 times, 0.12 for the mileage charge. Now, 2 times 15 is 30. Let's see, 120 times 0.12. 0.12 times 120. When I multiply, 2 times 0 is 0, and this will be 24. Put in a 0. 1 times 0 is 0. 1 times 12, I get 12. 0, 4, 4, 1. I have 1, 2 digits to the right of the decimal point, so 2 digits to the right there. So plus 14.40. When I add 30 and 14.40, I end up with 44.40, and these are dollars that we're working with. So $44.40 is what it will cost to rent this car if it's $15 per day and 12 cents per mile, and we rent for 2 days and drive for 120 miles. Next, we want to look at some formulas that involve pi. So let's walk back over here. I've written over here on the board some formulas that involve the number pi, and for us, pi we're going to estimate with 3.14. So here I've drawn a circle. It has a radius of r, and the radius is the distance from the center of the circle out to the outside of the circle. So that's the radius, and that's the radius, and it's r all the way around. 2 radii together like this is a diameter. So a diameter goes all the way across the circle through the center. My formulas are d is equal to 2 times r. The diameter is twice the radius. Circumference is pi times d, or 2 pi r, and the area of the circle is pi r squared. So those are the formulas that involve pi and the circle. The circumference is the distance around the outside of the circle, and the area, of course, is the amount of area it takes to cover the circle up. This is a right circular cylinder right here. It has a height of h, and the base is a circle with a radius of r. The volume of this is pi times r squared times h. So it's like the area of the base moved through h units of height right here, and that gives us the volume of this, or the capacity that that cylinder holds. Let's go to the board now and work our first problem. Let's find the circumference and the area of this circle, and it has a radius of 4 inches. So the circumference of this circle is going to be c equals 2 pi r from our formula. Now pi is 3.14 and r is equal to 4, so I have c is equal to 2 times 3.14 times 4. Now you know that multiplication is commutative, so I can multiply 2 times 4 and get 8 times 3.14. So I'll do that multiplication here. 8 times 3.14, let's see, 8 times 4 is 32, 8, 9, 10, 11, 24, and 1 is 25. So I end up with 25.12 because I had 2 digits to the right of the decimal point here, so I need that many in the answer. So that's the circumference, and those units are in inches. So the circumference is 25.12 inches for this circle right here. The next thing I want to do is find the area of this circle. I'm going to use a different formula. A is equal to pi times the square of the radius. So that will be 3.14 times 4 squared. So I end up with 3.14 times 16. 3.14 times 16, and I'll just multiply that out and tell you what I get. 50.24 square inches. So that's the area, and I won't actually show you that multiplication. I multiplied it out earlier, and this is what I get, 50.24 square inches. So that's a circle with a radius of 4 inches. I have a circumference for it, and the units are in inches, and an area for it, and the units are in square inches. Let's go next and find the volume of one of those cylinders. Find the volume, and here I have a right circular cylinder with a height of 8 feet and a radius of the base of 2 feet. So the volume for this is going to be, according to my formula, pi r squared h. So I'll have 3.14 times this radius squared, so times 2 squared, times the height, which is 8. So that's 3.14. 2 squared is 4 times 8. So 3.14. And then 4 times 8 is 32. So 3.14 times 32, that comes out, and again I multiplied it out already, 100.48, and it's feet to the third power, cubic feet. So 100.8 cubic feet for the capacity of this cylinder right here. Now you can see it's going to be cubic feet because I'm going to have feet squared here times feet over here, so that's feet times feet times feet, or feet to the third power. So 100.48 feet cubed. So that's a look at multiplication with decimal numbers and some of the formulas involving circles and cylinders that involve pi, which is itself a decimal number, 3.14.